And remember, just because I'm recording, see, I'm talking right now and I'm recording. I don't care if you ask questions. I mean, I want you to ask questions. The recording is secondary to the lesson, so definitely don't be shy to talk. Your voice doesn't end up on the recording anyways. The mic from my MacBook Air is not that good to pick up your voice. Anyways, let's take a look at animation. So, does anybody remember the function that you need to make things animated? Void draw. Yeah, it's like we typed it in a lot last year. Almost every project, like going forward from here, will require you to use this void draw function. So we've already met void setup. This is a function that gets called every time a sketch starts, right? It's the first function to be called when a sketch starts. That's why it's called setup. It's good to initialize things, kind of get everything set up. Oftentimes we'll put in things like size here. Size, I don't know what size I want today. I'll go 600, 600. Why not? So this is a good thing to put in size. And we're going to learn about variables. So another thing that we often do here is variable initialization. What are the initial values? What are the starting values for these things? Hit points get set to 100, and lives get set to 3, and all that kind of stuff. This is a good place to sort of initialize those things. And then we have void draw. Void draw is one of the main reasons processing was created. I mean, actually, I can't say that for sure, but I mean, it's one of the main reasons that it makes everything useful anyways. Void draw is a function that is automatically repeated at 60 frames per second, although you can adjust that. And that's what creates animation, by constantly calling this function over and over again. You don't have to do that. It's just automated for you. Just keeps on calling draw 60 times a second. And then if you change what's being drawn inside of the draw function, it creates the illusion of animation. So we're going to be taking a look at that right now. So draw function is called 60 times per second, or whatever your frame rate happens to be. I guess I'll just write per second because the slash looks a little bit odd. All right, so wow, magical animation, right? So if I was to draw like a line, say from 0, 0 to 300, 300, and run that, surely amazing animation will ensue, right? No, it's still just a line. Why isn't that animating? What's wrong with that line function that will not prevent it from being animated in any conceivable way, any visible way? And I guess another question is it being redrawn 60 times a second? It is, yeah. What's going on? Why isn't it moving around? Thanks, Norman. Yeah, it's being drawn to the same spot over and over again, right? Like, these coordinates are not changing, so it's just redrawing it over and over and over again. So in order to make something like a coordinate that changes over time, or if you will, varies over time, then you need a variable, right? You gotta have some sort of container for a number that you can manipulate, and it has a label as well, a name. So for example, I could create, well actually before we create, there's all these built-in variables in processing. They're really useful. Let's use those. So here's the first one we learned last year, was mouse X and mouse Y. Is it, oh yeah, it's a capital X. Oh man, see, even I'm rusty. I forgot too. You know it worked if it turns pink. Pink is the color for built-in variables. So these variables are secretly being updated by processing as your sketch runs. You don't have to update them. If you try to update them, I think it does work. You can set them to 0 and stuff, but then they immediately get reset again as processing updates them. So mouse X and mouse Y, I bet you know what those are. That's the mouse coordinates. So now every frame we draw this, it's going to draw a line from 0, 0 to whatever the mouse coordinates are. And that will change as the sketch runs. So if we run this, we have, oh, it's a line drawing program now. And it's not animated in the sense of like, you know, what's the word, like a movie or something, but it's definitely interactive and moving around with us. This I like to think of as my anime sunburst or manga sunburst drawing program. Like One Punch Man is like striking somebody in the face, like at the top left corner, and all these lines are coming out as the result. I'm pretty sure that's what's going on. Hey, how come they're all building up? Oh man, how do I get rid of these lines? Or what's the deal with these lines? Well, remember we're drawing 60 times a second, but it gets drawn on top of the previous drawing. So in other words, we're not gonna get any. It's just gonna build up on top of each other over and over and over again. But does anyone remember how to clear the screen every time? What do you think? Background, yeah. I mean, there's a number of ways, but background is the easiest way. So if I was to stick in right here, background, and you could choose whatever color you want. I'll choose 255, I guess, for white. Every frame it draws background, which basically means a giant rectangle that covers your screen, whatever the size of it is, and then draws the line. So now we're going to end up having a program that has a line that just follows the mouse. It's really the same program, it's just we're drawing over and over again on top of the previous one, and we're covering whatever we drew with a big white rectangle because of background. There you go. A couple other built-in variables that you might find useful and or amusing. There's mouse X and mouse Y. That keeps track of the current X and Y position of the mouse. There's also, and I'm going to stick it in where the zeros are, P mouse X and P mouse Y. P stands for previous frame. So it's the X and Y coordinate of where the mouse was last frame. And if you run that, you'll end up getting a squiggly line drawing program. Oh, I guess you won't. You'll just see a streak that's following the mouse. But it's not really illustrating what's going on. I'll just turn off background for a second. And you can see what it does. You'll see we get like a nice line drawing program. Woo! I don't know what I'm drawing, but that's not unusual for me. I feel quite comfortable in the unknown space of art. So what's going on? If I go really fast, you'll see it a little bit better. If I zigzag it around, you can see that they're actually just straight lines being drawn from the previous coordinate to the new coordinate. And if you go slow enough, because it's being drawn 60 times a second, those lines turn into squiggly lines. And last year we used that exact stuff to make a drawing program, right? When we click the mouse, you draw. We adjusted the weight and stroke and all that kind of stuff, the colors, and that was lots of fun. So that's those two variables. But if you wanted to do something where it was an animation that was sort of self-controlled, like the classic one we did last year to start off with was, I think, a rectangle moving majestically across the screen from left to right. If you wanted that to happen where you're not controlling it, like it's not going to the mouse, then you're going to have to define your own variables. And that was a source of some concern last year, where people weren't quite sure where to put them and what happened. So I definitely want to talk about that today. And I don't know if it'll necessarily clear up all of our problems, but that's one of my goals this year, is to make sure everybody knows where to assign variables, where to declare variables, what happens when you declare them in different places. And we don't know if we'll get there today, but we'll definitely try out some stuff. So here's what we're going to do. We're going to make a rectangle move across the screen. Woo! I know, it's exciting. So we're going to need some variables. So, and we're going to need a rectangle function too. So I'm going to draw a rectangle now. I'm going to get rid of that. Actually, I'll just comment it out. So I want to draw a rectangle. And I'm going to keep track of its just as x coordinates. We'll just make it go across the screen in the middle of the screen-ish. If I wanted to make it in the middle of the screen, I guess I would do 250 if it was 100 wide and 100 tall. Now, there's no x variable built into processing, so it underlines. It's like, what are you talking about? I don't know what you mean. So you have to do something called declare your variables. And we're going to declare it at a classic place, but we'll also see what happens when we declare it in other places. So a classic place to declare variables, and we did a lot of them last year, is right up in this space at the top of your program, before setup even begins. And this space is for what are called global variables. So this is information that is accessible anywhere in your program. And you could theoretically declare most of your variables up here. There is a danger to declaring variables up here, though. And that is something that we're going to do more of this year. And we sort of encountered it a little bit. Your programs can get really difficult to debug when all your variables are way up here. How an object or how your program is running is all dependent on these variables, and they're just sort of out there in the Wild West. Nothing is controlling them. Nothing is limiting them. Different parts of your program could be modifying them, and you're not sure what's going on with those variables. I spent a lot of time printing out variables last year. We'd print out to see what was happening to the console. So this space, although it's convenient, isn't always the best place. So stay tuned for more information about that. But let's go ahead and make our x variable. How do we declare our x variable? What do we do? What are the two things we have to do? Not sure? Well, what would it be? Just like off the top of your head, if you wanted to make the declaration for the x variable, what would you say? Yeah, Diane's got it. Int x. That's a great way to do it. So it could also have been float x. That would have been okay too if either of you wanted to do that. So what's this int and float stuff? So that's the type. So the variable declaration always follows this pattern. You do type followed by name. And if you want to get a really fancy word, identifier. Type followed by identifier. But that's just a lot of letters to say name. So you can say the type. In this case, we have int, and the name is x. And before you declare a variable, it doesn't exist. So this is like saying, hey, processing, I'm reserving the word or the name or whatever x to describe a variable. It's only going to contain integers. And just to remind you, the different types include int for integers. I bet you knew that. But float's not so obvious. That's for, the technical term is floating point numbers, which are decimals, basically. A number that can be a rational number, basically. It can be 1.5, for example, whereas integers cannot include 1.5. So I'll put rational numbers. Rationals? Is that a term? There's some other ones too that we've used throughout our time, and we've even declared our own. Some other ones we're going to be using this year include Boolean, which are like true/false values. Strings with a capital S for text. And probably use chars as well. Actually, we used chars last year, which is just a single like letter or symbol or something like that, single character of text. Whereas a string is several, or I guess 0 or more strings of text put together. What other variables did we use last year? Do you guys remember? These are the ones we're using right now. Yeah, thanks, Roger. Yeah, we used some other ones. So maybe I'll just go on the list. These are sort of the main ones that we're going to remember in the near future. But also, we use pimage, and that one stores pictures. What else? What else do we use? Maybe you're blanking, but that's okay because it's Monday morning, and I don't mind. But I bet you remember this. You just maybe weren't sure it's a variable. What about arrays? Yeah, that's technically a variable that contains a whole bunch of variables in it. So arrays and array lists. I'll just go to the next one. So these were data structures, but they're very much are variables as well. They're more complicated variables. They are objects, and we're going to get into that coming up, object-oriented programming. And then we made a whole bunch of objects, right? Oh man, how many objects did we make last year? All those tabs we had, bullets. What's that, sorry? Classes, yeah. So you make a class that defines a new type, basically. We had enemy class, fighter class, all sorts of different classes, and custom types through classes. So we can make our own types as well in the future. But right now, we're going to mostly focus on the good old int and float, because those are the standard ones we're going to use for animation. All right, so up here in global variables, that means that this x, whenever I refer to x, it's going to refer to that same variable x. I could talk about it in the setup. I could talk about it in the draw, and processing knows what I'm talking about. So in setup, hey, it's a good place for us to declare, or to initialize our variable. How do you initialize a variable? Well, you just assign it a value. So you can say something like x equals 0, for example. So this is initializing. We're going to start at 0 because that's where I want it to start. And you can start it wherever you want. Note that I didn't type int again. If I typed int again, I'd actually be making a new x variable. And it's really annoying that Java and processing lets you make two variables with the same name in different contexts. So don't do that. You just have to declare it once. Once you've declared it, you don't use the letters int anymore. Now you just refer to it by name. So I'm going to set it at 0. And if I was to run this program right now, it would put it right there. There's our lovely rectangle. It looks so good. But it's not animated, so what am I missing? What's missing in this animation? I got a variable. Surely that will make things animate, right? But what am I missing with that variable? It needs to do a little bit more work. Nice, Norman. Yeah, we actually need to change it, right? So right now it's always 0. So unless acted upon by an external force, it will remain motionless. Just stay where it is. So we can say something like x equals x plus whatever number you want, 1. So this is doing some math. But this isn't math the way you sort of look at it as an equation, right? In math class, if you saw that, you'd say, nope, that's not possible, Mr. Pelletier. There's no number such that it equals itself plus 1, right? 99 doesn't equal 100. So it's not an equation. What we're saying here is we're saying that variable x, we're assigning it the value of whatever it was plus 1. So it starts off at 0, and then it becomes 1, then it becomes 2, then it becomes 3, and so on, and eventually starts moving across. It'll look a little bit ugly right now, though, because background's turned off. So I'm going to turn background back on so that it clears every frame. And then I'll run it, and sure enough, we'll watch the majestic rectangle migrate across our screen, and it will look so beautiful and wonderful. And then it's going to wait. Where are you going, rectangle? No, come back. It's gone forever. How do we get it back? Or what would be one way for us? Like it's right now, it's going towards Mr. Harris's room. It's migrating. It's going to catch it in his hand. Rusik, what did you do to fix it? Yeah, and we're going to introduce that for anyone who's new as well. We can sort of make decisions. We can have things that are triggered by our variable getting to a certain value. So that's an if statement. An if statement is really useful for making a decision. So at some point we want to make the rectangle come back, loop back to the beginning, right? So we could say if the x-coordinate gets to a certain number, right? And we can just use good old math operators that you're used to from math class. Like we can say if x is greater than, what's the width of the screen here? 600? If it's greater than 600, then we do something. And I'll talk about the braces and the structure in just a second. But I'll just move this up so everyone can see. Actually, I'll just move that up. Okay, so I could say, oh, well, then let's reset x. I'll reset it to 0 again. Although that won't be very satisfying. We'll find out why. So here's how the if statement works. When you get to an if statement, it says, hey, is this true? If it is true, then it will do whatever code is in the braces. And you can put as much code as you want in these braces, by the way. But if it's not true, it'll skip the code that's in the braces. So in other words, when x is 0, it just doesn't do this. All it does is draw the rectangle and move it. And then until it gets to greater than 600, it's only doing this stuff here. It does check if it's true every time, but if it's not true, it doesn't do this. And eventually, it will be true, right? Because we're increasing x, eventually it's going to get greater than 600. When it does, we reset x back to 0. To speed up this demonstration, I'm going to change x by 5, just to make sure we don't sit here waiting in suspense. There it goes, here we go, zoom, and then it reappears over here on the side. So we get an animation loop. How do we fix it so it doesn't look like it's teleporting into like the beginning there? Like it just like pow, just appears all of a sudden. What change should we make in our program? Yeah, let's make it appear off screen. And just in case you're wondering, because we talked about how the coordinate system doesn't include negative numbers, you can position things off screen. So I can say negative 100. It just won't be drawn on the screen. But that's perfect, because now I don't have to look at it like just magically appearing. It'll look like it's sliding off of the screen. There we go. All right, so there we go. We got some really basic animation. So let's see. I think I'm going to turn it over to you guys to start doing some animating. I guess first of all, make sure that you can control this. Like you could do this without too much difficulty. Make something else moving along with this program as well. Maybe make it move vertically from bottom to top and then loop around again. And then when you're done that, we'll try something a little bit different, maybe with making something move like a bouncing ball or something. So it's like it's falling and bouncing when it gets to certain positions. We'll animate that together. Okay? So if you want to get started on the bouncing ball earlier rather than later, you're welcome to do so if you're excited about that. I'll stop the video because that's the basic information to learn about, but we'll have some other things we're going to talk about later on.